Hi, this is lesson 6.8, Estimating Decimal Products and Quotients. For the math message, you know that 2 and 4/10 times 1 equals 2 and 4/10, right? So, will 2 and 4/10 times 1.8, 1 and 8/10, be greater than or less than 2 and 4/10? How do you know? Jot that in your notebook. When you're ready, come on back. Well, I hope that you remember when you multiply a whole number by a fraction less than 1, the product is less than the whole number. So, for example, 6 times 2/3 is less than 6. I hope you also remembered that when you multiply a whole number by a fraction greater than 1, the product is greater than the whole number. So, for example, 6 times 3/2 is greater than 6. So, 2 1/4 times 1 and 8/10 is greater than 2 1/4 because 1 and 8/10 is greater than 1. But 2 and 4/10 times 6/10 would be less than 2 and 4/10 because 6/10 is less than 1. Hopefully that's what you had. So some rules for estimating decimal products. Jot these down if you think they're going to help you. The first one, if the second factor is less than 1, the product is less than the first factor. If the second factor is greater than 1, the product is greater than the first factor. If the first factor is less than 1, the product is less than the second factor. And if the first factor is greater than 1, the product is greater than the second factor. We've been talking about this for a while, so I'm just going back over those rules for you. Remember when we were estimating products and quotients with whole numbers, we used close but easier numbers, round numbers I like to call them, right? We can use a similar strategy to make estimates for decimal multiplication problems. We can round the decimals to close but easier whole numbers and then multiply. So here's one for you to try. So use close but easier numbers to make an estimate. When you think you're ready, come on back. So hopefully you said something like 10 times 200 equals 2,000. 10 is a whole lot easier than 12 and 8/10, and 200 is a whole lot easier than 185 and 3/10. They're round numbers close enough to give me a good ballpark estimate. Hopefully you had something very similar to that. If not that, I hope you had that actually. Here's another one. 896 and 1/10 times 2 and 7/10. Jot that in your notebook. When you think you're ready, come on back. Hopefully you said, I could do 900 times 3, knowing 9 times 3 is 27. I'm going to take the 2 zeros, so it's 2,700. I hope that's what you got as well. All right, one last one, maybe a little bit trickier. See what you can do with this one. When you're ready, come back. Hopefully you said, well, 9/10 is really close to 1, and if I'm multiplying by 1, I can just keep that second factor. Now, so I'll keep that at 3/10. 1 times 3/10 is 3/10. I hope I didn't fool you. All right, try this whole problem. So 110 times 2 and 8/10. 11 times 28 hundredths. 11 times 2 and 8/10. The product of one of these problems is 30 and 8/10. How could you figure out which problem has a product of 30 and 8/10 without calculating? Use estimation to show that your reasoning makes sense. Jot this down. Pause the video, figure it all out, and when you're ready, come back. So one possible solution would have been that you said 110 times 2 and 8/10 is close to 100 times 3, so we can expect that the product is around 300. Well, that's way bigger than 30 and 8/10. 11 times 28 hundredths must be less than 11 because 28 hundredths is less than 1. So 11 isn't really close to 30 and 8/10. 11 times 2 and 8 tenths, however, is very close to 10 times 3, which is close to 30. And that's close to 30 and 8 tenths. So there you go. Now we have our winner. Notice that the digits in the factors of these problems are the same and in the same order. Right? You see that 11028? Same in all of them. The only difference is that the decimal is in a different place. So if you solve the other two problems with a calculator, you will see, well, you can go ahead and try it if you'd like. And then I think you're going to see that there's a pretty obvious pattern in the products of all three problems. Why don't you go ahead and prove that to yourself? Pause the video. Okay, so hopefully you saw that they all had the same numbers in the products as well. Just wherever the decimal was different. So here's another strategy for you. When you have an estimate for the product, you can place the decimal in the answer. You don't have to learn to multiply with the decimals in it. You can just multiply and then place the decimal. So you knew the digits would be 308. In each problem, your estimate helps you place the decimal, right? So the first one, our estimate was 300, so 308 would be where the decimal would go at the end, where you don't have to write it. For the second one, 3 and 8 hundredths, because we knew it had to be less than 11. And for the last one, 30 and 8 tenths. And we knew each of those just based on our estimates. That's pretty handy, right? Okay, we can do the same strategies for division. That's happy. So let's look at 82 and 6 tenths divided by 7. How would you estimate a quotient for this problem? Pause me, figure it out, and push play when you're ready. Hopefully you would have said, well, I could do 80 divided by 8, and that's 10. Those are easy numbers for my brain, right? So if you knew the digits of the answer are 118 for this problem, where would you place the decimal? Hopefully you would say, well, I said it was going to be close to 10, so if it's 118, it would have to be 11.8, right? Because that, if I put my decimal there, is going to give me pretty close to 10. And if the problem was 8 and 26 hundredths divided by 7, where would you place the estimate then? Well, if you said 8 divided by 8 is 1 as your estimate, wouldn't you say this is where the decimal would have to go? Yeah, I think you would. Okay, so the following quotient includes the correct digits in the correct order. So use an estimate to place the decimal. So I'm telling you, this is all correct, but it needs a decimal in that quotient. How are you going to figure that out? Pause the video and try and figure it out. Come back when you're ready. Hopefully you would have estimated 40 divided by 4 equals 10. And if 10 is my estimate, then the decimal would have to go 13 and 5 tenths, or 13 and 50 hundredths, right? Because 10 and 13 are close. It wouldn't be 1 point something. It wouldn't be 135. It's certainly not 1,000. 13 is very close to 10, so that answer makes sense. Let's try another one. So these numbers, again, are totally correct. You just need to place the decimal. So 2 and 52 hundredths divided by 6 tenths equals what? Try and figure that out when you're ready. Come back. Hopefully you would have said, this is a little trickier, but hopefully you would be able to say to me, well, I could do 2.5, 2.5, and I could divide that by 5 tenths, because I know 5 tenths is half, right? So how many halves are in 2.5? There's 5 of them. That's how I did that problem. Definitely trickier, I know. But hopefully you can follow that logic. And if 5 is my answer, my estimate answer, there's only one spot that decimal could go, right? 4.2. It wouldn't go 0.4. It's not going to go 42, 420, or 4,200. The only way to be close to 5 would be where I put it at 4.2. All right. Your turn to go practice on your home link 6.8 in Google Classroom. Have fun.